Assalamu alaikum. Today, inshallah, we're going to talking about Maryland bridges. These are the most famous names for Maryland, the bridge. But as a scientific term, we usually should say resin
Pontic
bonded bridge. Okay.
or resin retained.
Or retained, resin retained or resin bonded bridge. These bridges are a group of bridges, but the idea is that when you go into the differences between the new material and the old material, you need to differentiate between a lot of terminology. So we're going to revise the terminology one by one. Okay, first of all, we have different techniques for placing something bonded to the tooth, holding a pontic. So first of all, we're talking about a bridge because there is a pontic missing. Okay, there is an area of a tooth missing, and we're replacing a pontic, and we are taking the adhesion from adjacent teeth. Okay, so there are some direct techniques to do this. So I'm inside the clinic, so there are direct techniques and indirect. The most famous are the indirect. What do we mean by indirect? Made inside the lab. Okay, then under the direct we will have different techniques for the anterior teeth and posterior teeth. Same thing for the indirect, we'll have different techniques for anterior and posterior teeth. Okay, this is one of the types of classifications we have, having it direct or indirect. The second way they classify these bridges or these materials is by the mechanical retention they get. So by retention. Okay. So we will have some that are mechanically retained. There are something called macromechanical. And then we will have
Electrochemical.
chemical. They call it chemical. And the fourth type is what? What is the fourth type? Micromechanical, chemical, and mechanical, and chemical. Oh, mechanical by itself. Okay, so micromechanical, macromechanical, mechanical, and chemical. This is large. You can. Okay, we're going to talk about them when we talk about the names underneath each one. So these are the ways that we bind to the adjacent teeth. Okay, so the type of retention. Now each type of retention has a different way of cementing it. So the cement or the bond that we are using, or if I'm using a bond, the way I'm bonding and cementing is different between these three. Okay, then we have another way where they classify the material by the names that we have. We will have them called bonded pontics, then we will have cast perforated, then cast and etched, then chemical bonded, then cast mesh shape, and then we'll have Virginia. They put it alone sometimes in some of the books, and ceramic retainers. Okay, so what is the bonded pontic? What is the bonded pontic? In some cases, we have bonded pontics come in two forms. Either where I put the pontic as a natural tooth, so it's the tooth itself naturally. After extracting it, why not put it back for a temporization period, for the healing, without losing the aesthetics of it? Okay, so what do? They take out the natural tooth, they cut off the root, they keep part of the root like an ovid pontic, and they fill it, they empty the pulp tissue, they fill it, and they place the tooth back into the position between teeth, binding it to adjacent teeth. Okay, so how do we bind it to adjacent teeth? They place composite and acid and etch, and composite, acid and etch, and they bond it to the adjacent tooth with a bulk of composite between the teeth. They bind it back. Some methods, they add a band of fiber material, like ribbon or other fibers, e-fibers, behind the tooth, and they bind the fiber also from the palatal lift. So if this was the palatal surface, after they bind the tooth with composite on the sides, they would add also a band, and over that band they will put flowable composite. So you can do it with a natural tooth itself. So the natural tooth, to keep it in place, we have to empty the inside of it, cut the root because no longer we're in the socket, and shape the root, the remaining root. We keep some of the root to work as a shape, guiding the gums to heal in the root shape and maintaining the interdental papilla. And then we are going to put the tooth back, the same tooth from behind, binding it on the sides with the composite and also binding it from behind with a band. There are some acrylic teeth. We could do the same thing with acrylic teeth. Once more, we bind it to adjacent teeth with composite, and from behind, with acrylic teeth, we need the band better. We need to use a band in this case. And in that, to make the band run in the tooth without adding bulk to it, they hollow the tooth as a groove. There is a groove, in empty groove like this. And in this groove, they place the band running through. Okay? So this is the bonded Pontic. So it's a Pontic. There's no extra, nothing done. This is a direct technique. There is no metal framework or something done in the lab, and they place it immediately. Okay. Then we have the second type, which is cast perforated. Now this cast perforated is the same as what they call rochet. Okay. It's cast and perforated, meaning that, and this is the same as mechanical. This is the same as what we said, it was mechanical. So cast perforated. So how does this bond to the adjacent tooth? This is one of the chemical. So it binds by composite. Acid etch, and then composite. So all of this is chemical. Now, the second way is cast perforated. There is a Pontic that is made by the lab, but we have wings binding to the adjacent teeth. These wings are designed in a way that they are perforated like a mesh. So the cement or the composite or whatever we're using to bind it, I'm going to leave that for you in the task to see what is the cement for each type of Maryland. The cement or the bond will come out and through the tooth, and it will bind inside and out. So it's going through these holes. So it's like tags. So this is what we call mechanical retained. And this is what we find in some books, they call it rochet. Because he's the first one to describe this technique, rochet. Okay, these techniques have problem with the longevity of the procedure, so we went to another type of working with it. Okay, now going to the cast. Okay, etched cast. This is the regular Maryland. They call it a Maryland in short. So how do they do it? They make this Pontic, they add it to the framework by porcelain, could be dilithium silicate, different techniques. But the idea here is what do they do to the metal? The metal, they acid etch it. We have different types of acid etching. We have direct or electrical guided. And the direct itself has different acids. We have different acids with different concentrations. So what does the acid produce? It produces a rough surface on the inside. This is why it's part of the micro-mechanical. This is micro-mechanical. Okay? So what I see a matte metal surface. Matte, it's not shining from the effect of the acid. So this is called a matte surface produced by the acid etch, whatever type of acid etch is used, and it's micro-mechanical.
This is Virginia, Doctora?
Not Virginia.
Oh.
Okay. We're going to talk about the
Virginia
Virginia in a
meat
moment.
roughness.
In a moment, yes. And how does this bind to the tooth? Regular cements, could be resin, and so on. I'm not going to tell you a lot about the binding because this is part of your task. Okay, we're going now to the chemical bonded type and the cast mesh. The chemical bonded type it depends on the type of the bond they add, and that is they usually use a meta bond for it. Okay, this is just talking about the type of cement. It doesn't have a lot of work to say about, but then we're going to go to the next type is the cast mesh. Now if I look at the metal here in the cast mesh type, I will find that they have placed inside the pattern a nylon mesh. So it looks like a nylon, like a pattern, like a fabric shape. So it's a part of roughness produced by a nylon mesh, and this type is called cast mesh. Now the Virginia bridge is another way where they place the Pontic, okay, and inside the pattern they place some salts inside the salt particles. These salt particles aid if you put something smooth over something rough as salt particles, what will happen? They will produce some roughness in the surface. These salts are then dissolved in the acid, small acid bath and the cleaning in the cleaning process. So what do they leave? They leave a shape of salt particles inside the pattern itself. So this is another way, and this is the one called Virginia. Okay. Then finally we have now the ceramic retainers. They depend that they are made out of ceramic, and usually they are cut in one piece. They are cut by CAD/CAM systems. You have multiple systems, the Procera, you have the ExoCAD, you have the plan scan technique, you have different types, you have 3-shaped dental systems, and all of these depend on ceramics or dilithium silicates to form their material. But of course the zirconia is the best, and now with the new evolution of monolithic material we can use these ceramic retainers. Okay, so they are ceramic retainers. So which one is mechanical? Going back to this one type of retention, which one is mechanical? The cast perforated. Okay, macromechanical is the mesh, the nylon mesh and the Virginia. Macromechanical, because I could see the areas that the cement is binding to. It's more large. Okay, and what is the chemical?
Russia, the first one.
Depending on the bond, what bond you're using. What is the micromechanical? Is the Maryland, which is acid etched. Okay, so now we know we now relate the material to the type of retention.
هو الميريلاند بس الاسم للأسيد etched.
لا acid etched, yes. This is the known name for it. Okay. Okay. The other confusions that come from resin bonded bridges is about their shape. So we have the shape of the bridges, of these bonded bridges. The shapes differ between different systems, but the idea is either we have it conventional bridge or we have it as a cantilever. Okay, so this is another way they classify these resin bonded bridges by the way they are bonded to the teeth. If they are a conventional bridge is bounded to 2 teeth. Okay, so the wings go over
2 retainers.
2 retainers, yes, abutments. Okay, so these abutments, and we have a Pontic in between. This could be 1 Pontic, by the way, 1 Pontic, or 2 Pontics maximum. 2 Pontics are usually left only for the lower, are preserved for the lower. And wherever we have 2 Pontics, we should have 2 wings, because we want more retention. Okay, so we get a benefit of having 2 Pontics, usually these in lower teeth only, in the anterior teeth where we have problems of mobility, and and many times you extract the centrals and you are going to leave the lateral. But whenever we have two pontics, we're going to have two wings. So the wing extends not only one tooth, okay, but to two adjacent teeth. So we have, okay, let me do it as a lower. Let me draw it as the lower. So these are the lower teeth. So I'll have two lower teeth. Okay, these are bonded to two adjacent teeth, okay? Because we want more retention.
So retainers on each side.
Yes, on each side. So two pontics is confined in the lower arch only, and in the anterior area. Usually it's one pontic, and this is the conventional way. The cantilever is having the tooth, the wing only bonded to one tooth. Why? Because I want to reduce the tooth mobility. Because if I have two teeth, the idea over the cantilever design is what? And it's proved to be more successful than the conventional with two wings. What is this? The idea about it? We know that the teeth move naturally in their location. So suppose I have these teeth. Let's say this is the arch, dental arch. Okay. These teeth move in this direction. These teeth move in this direction. These teeth move in this direction. So the path of escape, they call it fremitus. You know this fremitus? It's the natural movement of the tooth in the socket. So these types of movements in the socket are in different directions. These cause different stresses. So if I'm placing a bridge and it's bonded to here and here at the same time, this is working in this side and this is working the other side. So the path of the movement of the bridge and function is different. So that makes us have debonding and usually debonding happens at one end, not both ends, okay? So to solve it, they said, why not place a cantilever? Okay, so this is another way how they describe these bridges as conventional or cantilevered. Okay, so this is sometimes where the confusion comes from.
So الكانتليفر نعمله باللور كمان.
Cantilever in the lower, this is part of your homework, so I'm not going to go into that. Okay, it's part of your test. So now the new thing in I'm trying in this demonstration to tell you what's new about what's the difference between what you have in textbooks and what's new. Something new here is as well are the indications of these. We have a new indications. Now, what is your conventional indication for resin bonded bridges? Conventional. Single missing tooth.
Interim.
Okay.
Interim treatment.
Interim? No, it was a permanent.
I know that. Yeah.
Convention. This is the conventional. So it's a permanent, okay, solution for one tooth missing. Then now, what is new about it? I could use it for more than one function. One of them is temporization. Good. Temporary over what? For what?
I meant
Why?
the patient, 16 years old.
Yes.
She want to missing lateral. She want to put an implant.
Okay,
But-
and she's not ready for implants.
Yes.
We know that implants are placed usually after 18 because we want the bone in its final growth and size, and as well we want the gingival margins to have finalized their
conservative option until
So temporization. What else? Space maintenance in children. Sometimes if they lose posterior teeth, we could use them as a space maintainer, especially if we make it a cantilever. Okay, so to avoid the tilting of the teeth. What else?
I could use for splinting, periodontal involved.
Yes, plenty. The same wings, we could add to them, they splint teeth together. So they act as a splinter for periodontal disease. What else? Temporization, long-term temporization over implants. Implants, because we want the implants to osseointegrate. So if we want the implants to osseointegrate, we want
Over
something
implant.
temporary.
Okay.
And we could not place a partial because the partial sometimes with the pressure it exerts on the soft tissue will traumatize the soft tissue and maybe prevent the healing of it. Okay, so we are afraid that the healing is compromised. So having the implant there, we want something held away from the tissue. So the Pontic is usually retained by the adjacent teeth and doesn't touch the tissue. So this is more preservative than doing a partial denture. Okay. What else? We have the last case in cases of medically compromised patients. If medically compromised, then I cannot do surgeries. They could not tolerate something mobile as a removable partial denture. So the medically compromised patients, sometimes we need to use the Maryland. It's more stable. But once you do a Maryland, there are some contraindications. It's part of your task, but the idea is that there are some cases where you should be careful that the patient, if he has a Maryland, it's written in their medical records, because these are not very well retained and they're small. So if in case they need a hospitalization and they need intubation, these are in risk to fall off and come into the respiratory tract. So if they have Maryland bridges attached or adhesive bonded bridges attached, these should be clearly written. And the good thing, this system may not be in all countries, but dental and medical records are in the same place. So the anesthetist would take care if they have a resin bonded bridge when they intubate the patient, okay? In cases they need general anesthesia. Okay. So medically compromised patients. Okay. Now we're talking about the anterior and posterior. So this is another way they differentiate by location, because different anterior resin bonded bridges are totally different than posterior, so? Okay, so anterior and posterior. How are anterior retained? The difference here is talked about the preparation. What are the differences between anterior and posterior? The preparations, design. What else?
Interior.
Anterior and posterior.
Material.
Material, yeah. What are the differences between anterior and posterior?
Cementation.
Maybe cementation. Okay.
occlusion دكتورة مختلف.
Occlusion. Because occlusion is one of the points that we have to take into account when we are placing pontics, okay? So, posterior pontics have different preparation designs than the anterior ones. So we have to also understand the difference between them. The longevity of them are different as well. So this is also part of your class. But what I'm trying to get is to join together all of the names that you have. Okay, so if I say a butterfly bridge, what is this?
Interior.
I'm going to tell you names now, and you're going to try to classify them. Okay? Butterfly bridge,
Interior.
is that material?
No, anterior.
Anterior only? No, it's a nickname or a general name. How do we say gums, and we talk about gingiva. Gums is the general name. So butterfly bridge is the one that is bonded, resin bonded. It's just a nickname or a general name that people use on the internet. So it's called butterfly. The Maryland
Yeah,
is
it's
the
a-
cast and acid etched. Could be interior, could be otherwise. The Maryland name, Maryland. It's the way that it's constructed in the lab. Okay. E-fiber bridge.
اللي بتلزق بالسمنت.
E-fiber is using fibers in between. The fibers could be, and this is one of the differences between anterior and posterior. If we're going to use the anterior fibers, as I told you, we will make a groove in the pontic
هذا الدايركت.
and then add to it. Or it could be a male-female connections. The tooth could be with metal connectors coming out of the tooth, and those are bounded with the aid of resin. So anterior and posterior, these could be inlay, or these fiber hosts connect between a class 2 and a class 2. So they called inlay bridges. Okay, inlay retained. Okay, so what is a ratchet?
كان عنه.
What is it? The perforated, cast perforated.
Yeah.
Okay, 3-shaped dental system. It's one of the ceramic systems where you do digital design and you do a digital CAD/CAM work. Okay, a pen ledge. It's a terminology related to the preparation of the bridge itself. Okay, we're going to talk about that in a moment. Procera. It's also a ceramic. ExoCAD is a type of ceramic. Plan Scan is a type of imaging and design. Virginia. Okay. The bonds themselves, the fibers themselves have different names. We have the ribbon, we have the E-fiber, okay? We have the fiber band, different companies with different names, okay? Material, what are material? Okay,
Personal choice.
okay. We have them. Now the conventional material used are either ceramic, porcelain. No, they are not strong enough. Porcelain material is not strong enough. Okay, it's a glassy phase. It's not strong enough to place a bridge, so it's ceramic. Or alloys. خلينا نحكي base alloys or precious alloys. And the Pontic is made out of porcelain, bonded to the regular alloys with porcelain. The Pontic is porcelain, but the retainers are metal alloys. They could be precious alloys or base alloys.
بس هذا ما بنسميه PFM.
No, not PFM. No, PFM are usually called the name for is preserved for the tissue. Sorry, the name is preserved for the crowns themselves. Full crown. Okay. So there is another way to classify the material. It's not actually classification, but it's the way that we deal with the soft tissue beneath them. What are the soft tissue procedures beneath them? Okay, we're going to place a Pontic. We could place that Pontic either over a socket. So as we do in immediate denture, we plan it before. So on the day we extract, we place it over the socket, okay? And usually when there is a socket, why not benefit in doing gingival reshaping and preserving of the tissue? So part of the tooth will go into the socket, okay? So this is the socket. Part of the tooth of the Pontic will come into the socket. It's designed in a way, so it will have like an emergence profile as it's erupting from the socket, okay? So part of the tooth, 2 to 3 millimeters inside the socket, it will reshape preserve the interdental papilla, preserve the socket shape, and make you as if it's emerging from inside. Okay, so it's either socket or
extraction.
yes, in the same. It's this. You do your preparations and you do your impressions before you extract the tooth. So on the day you do the extraction, you place the emerald immediately. Blood. The way you bond when blood is there is that on the socket itself they will place a pack for 10 or 15 minutes until the bleeding stops. So there is no active bleeding, meaning arterial bleeding. There is only the oozing. So under pressure the oozing stops and you will get a clot. So this is how they do it. Okay, good question by the way. Healed ridge, and then we will talk about usually the designs of Pontics. Usually in these cases, in healed ridges, we do a modified ridge lap, only anteriorly. It's lapping only anteriorly. Okay? Then it could be, what else underneath it? There's an implant. If there is an implant, the Pontic will aid also in the design of the soft tissue and maintaining the interdental papilla. Okay? Or there could be a connective tissue graft. If you want to shape and increase the depth of the or the thickness of the soft tissue beneath it, we're going to place a connective tissue graft beneath it. So it will also aid in the shaping of the connective tissue while healing and taking the shape of the gingiva. Okay, so we could place connective tissue graft in cases we could not do bone augmentation. Okay, and we have lost some of the alveolar ridge. It will appear like black triangle beneath it. So why not augment either the bone by bone procedures or augment the soft tissue by connective tissue grafts. Okay.
دكتور يعني إذا كان في سكت أو إمبلانت بنحط نفس البونتيك هاي اللي هي الأوفيت.
Yes, الأوفيت. Yeah. Finally, in the preparation, this is what we're going to do in the demo. Just to talk about it a bit. It's like the window technique of veneer, the same window technique. Okay, but it's from the inside. The preparation of the tooth is from the inside. added to that design, which is like a window veneer. So what is a window veneer? We have a finish line all around. Okay, add to that there is a wrap around the tooth. We should wrap 180 degrees because we want some resistance. Want it to hold to the tooth, and we place the grooves on the proximal surfaces close to the anterior finish line. Okay, it looks like the one we've done in the 3/4 bridge. You remember the grooves that we place? But these grooves don't have a slot in between, just the grooves. Parallel grooves, parallel to the path of insertion. Now, how do I aid in my retention resistance? There are two types. Some people, I've seen some videos where they just do a single rest, a flat area here. This will prevent the bridge going in. This is called a ledge. So this is what we call ledge type of retention. Some people place this ledge 2 here and 2 here. So 1 on the cingulum and 2 on the sisal edges. How do they do this? By an inverted cone. Bear. Simply this bear, you go close to the dentine and it will cut this triangular shape of ledge, a flat area in the tooth. Now some people do, after they do this, they do a pen inside. So it's a pen ledge. The pen, how much does it go in? The initial cut is 1 millimeter, the final cut is 3 millimeter. And you bevel it from the outside, so it's not only a pen, it should be beveled on the outside so it's a bit wide, so it will have a good escape of the cement into it. And it should have very careful impression procedure to catch these pen into your model. Okay, so it's either a ledge, so 1 cingulum ledge, 2, 3 with 2 on the incisal, or 3 pens, depending on the path of insertion. Of course, we have proximal undercuts. These proximal undercuts should be reduced to gain a path of insertion for the bridge. Okay, so if there are undercuts, we have to remove them from our preparation.
ترى الجروفز إيش بعد يعني نعمل الجروفز.
Yes, the grooves aid in the resistance. Okay, you could say I could not place the grooves, and even with the ceramic types, I'm depending totally on the bond. But why not add an extra feature for resistance? Okay, this is an extra feature. You know that when we have the wrap, this retains that for a longer time. If we have the grooves on the side, it will aid in the wrap, the 180 degrees. Because if I want to do a true wrap, that means I'm going on the labial surface. I don't want metal showing on the labial surface. So what do I do instead? I do grooves. So they will aid, the direction of them will create like an 180 wrap without going to the labial surface. Okay.
Wrapping, I will not cross the contact.
No, you don't cross the. How am I going to do the wrap? If I'm looking at this incisally, okay, good question. Okay, this is the tooth incisally. This is the central, for example. This is the incisal edge. So I'm cutting here, then I'm doing the groove here. So I'm cutting this like a veneer, similar like veneer. I'm doing the groove before I reach the label and the contact. So this now, if I'm talking about this material now, it's trapping more than 180 degrees, صح? It's going beyond 180 degrees, but going into the grooves they created, not by going on the labial. The 180 degree encirclement is created by the material going labially, then going into a groove placed just before the incisal edge and the contacts. So it creates the wrap. So it's more than 180 degrees now. So it's a retention or resistance.
أصل الجروف دكتورة بالطول قصدي.
Yes, a tool. هيها. It is a longitudinal cross.
And the
running
finishing
to-
line all around.
Finish line should be all around.
Incisally.
Now there are some types, and they claim that you could place it without preparation even. But once more, the technician should know where to end and when to begin. So the finish line purpose is to remove part of the enamel and show the technician where are your margins that you want your procedure.
ترى إنها single path of insertion بيكون.
Yes, and both teeth should be in the same direction. You will see them in the videos that I posted for you. I put some recommended videos in the channel called recommended YouTube videos for fixed prosthodontics. And in them you could see these types of preparation. You could see everything I've talked about. You could see videos about how to do the putting a tooth in a socket, how to do a natural tooth, how to do connective tissue grafts, whatever you want. The ideas I collected, I put them in that channel. Okay. But the purpose of this is to gather all of the subject together, so you could get a good grip of the subject and would know and understand the subject without being confused. by the terminology. So the terminology will not shift your attention away from the general ways we classify these resin bonded bridges. Okay? Any other question?
يس دكتورة اللور لما نعمل توب أباتمنتس جنب بعض نعمل كل واحد لحاله زي كأنه كوب لحاله صح؟ ما بنفتحهم مع بعض أو شيء.
مرة ثانية.
لما نعمل two abutments جنب
Two abutments over each other, around each other. You go slightly into the embrasure. Her question is about what if I have the, okay, this is one tooth, this is second tooth, and this is the missing area, and I want to make a pontic, okay? This is, for example, the canine, the lower canine. So we're talking about how do I open them. Okay, it will be like an extended plate. So you don't open it,
واحد لحاله.
everyone, each one alone, and in the embrasure, the metal will be connected. Okay, so it's a double retainer on one side. Any other question?
دكتورة the longevity in double retainer it's the same when it's single retainer?
This is part of your task.
Okay.
Okay, so the second video will be our task.